Okay, to start this discussion, I will ask my own question, and then we'll transition to the questions of the people who are submitting questions to Menti. So I'm asking mostly Fluence and Tableland and Lilypad. Matt, if you have opinion, would be also great. Like, what is the main reason that you choose to build your project with IPC? Because nowadays developers clearly have a choice, and I was curious what were your reasoning, and maybe you can throw in a feature of IPC that you're most excited about.
I'm going to say one thing and then pass the mic to Luke. Fast block times and low gas fees. That's very much, I think, where we were at, because we needed on-chain scheduling and on-chain deal finality, and especially for kind of like users who wanted just to have the AI image back, like as in they don't really, in our minds, a large amount of people who might want to use Lilypad might not want to really concern themselves with the infrastructure underneath, and so like, hey, you have to wait 7.5 hours in the extreme case would make it not work. So I think it's the efficiency would be the one word answer right there. But here is the better version of Luke.
Thanks. I mean, you can join us if you like, huh?
Oh, no,
Okay. Cool. Sorry, I was late. What was the question?
The question is, like, what was the main reason you decided to build on IPC platform?
Yeah.
And what IPC features you're most excited about?
Yeah, I mean, what Kai said, basically, it's like fast and cheap. And we need that for our use case because we have an interactive use case where a user will, for example, maybe users will build applications that use AI to generate images based on their input. They can't be waiting like multiple rounds of 90 seconds for feedback in their interactive applications. We have if an inference takes 12 seconds, I'd say we have a budget of about 4 seconds. On top of that, we don't want to go over that in terms of like scheduling overhead, like infrastructure overhead from like running it on a blockchain. So yeah, fast and cheap is necessary. So there's the fast and cheap is like the time aspect. We get maybe a 12-second budget. The inference itself maybe takes 12 seconds, and then we get a 4-second budget on top of that. In terms of cheap, like these inferences are not very expensive. You need to do a lot of them. Stable diffusion inference we might bill for like 10 cents, like 10 cents US. We wouldn't want to add more than 1 or 2 cents of gas fees on top of that. So that gives you a sense of like the kind of constraints for our use case.
Yeah, I understand. But in the same time, IPC is not the only game in town for fast and cheap, right?
Mm-hmm. Yeah. I mean, another aspect is that we kind of come from the PL ecosystem, so it's natural for us to want to find solutions in that space.
Cool. Thank you.
Yeah, I can extend on that one, but it's worth saying we haven't decided to build on IPC yet. We're still really evaluating it, and my answer includes the dependencies, part of the dependencies on whether or not we would build on it. But fast and cheap is a big one. So if you imagine the state of data changing, you want it to be happening really quickly. The other things that we're looking for, and so other actors in town, like we did explore Cosmos, for example. Something that Cosmos has right now is really good UX, right? So, but looking for that here, we're also looking for customers, obviously, and making sure that they're going to match what we build. But one thing that we're really drawn to here is the hope for interoperability with the underlying storage layer. So being able to touch and create data that's stored on that permissionless layer that we don't have to build again. Every other case of building that, except for sort of creating it in smart contracts, is kind of like an air-gapped solution over it, and we're looking for something that's more tightly bound to that, where you can suddenly get all the all the value of that and pass it on to your users, but then create something new on top of it. That's really what we're exploring there. And then the fast and cheap is obviously a strong requirement of that.
Can you elaborate a little bit on the storage layer, like how you plan to use it?
Yeah, so in that like 3-layer stack where you have the EVM that controls access control, in our use case for this piece that we're exploring right now, you have like the EVM controlling access control rules and membership and all of that. Then you have this middle layer, which actually is the database execution, which says, okay, these SQL statements came in, this is how it changes the data. And that's like the hardcore piece that we don't want to have to build in IPC right away, but we can build the data availability piece right away. And so that data availability piece kind of has 2 requirements. The first requirement is the data that's coming into it, we can make it available, but we don't want to go ahead and recreate another storage network. So ideally, we can make it available with a more slacked sort of guarantees, but then that data flushes to Filecoin with guarantees, and suddenly you have it there, but you have all the longer, all the longer times that you'd have to wait for those guarantees to show up. But the other one that gets interesting, which isn't a hard requirement yet, but it makes it, doubly interesting, is if we can bootstrap state from Filecoin. So like either bootstrapping the state of a whole new subnet that has gone away, or being able to pull pieces of the state back from the subnet. So if you imagine like TTL in a CDN, that TTL can expire, but if it expires, typically you can go back to the origin. The CDN can go back to the origin and pull it back out. And so could we do that?
Yeah. Thank you. Evgeny?
Yeah.
Do you want me to repeat the question? Or?
Yeah, I remember that. Basically the same here. Like first argument is being close to data, being close to storage deals, because it's kind of like ideally from user experience perspective, whenever user pays for compute, like we want them to pay for compute and the data sort of together. Ideally, we should be on the same chain to do it, because like all the bridging and token conversions are like really real pain. And the other thing is basically like being close to data itself, and cheap and fast, of course. And the other thing, like what I mentioned in the talk, we wanted to have ability to customize stuff. Like as like WASM actors was not ready on L1, we thought maybe we do it on L2 ourselves, or maybe we run natively RandomX like aside even without WASM. So it's still kind of research work in progress, but the fees on L1 will anyway push us to L2. We have no other choice. That's the only solution possible.
Yeah, as been said, fast and cheap, but also the other part of that as well is finality. So on layer 1, it's whatever it is, 7.5 hours is the kind of I can't remember how many epochs it is the kind of the accepted kind of definition of when it's final. It's probabilistic, obviously, but when you're doing something like a bridge, so companies like Axelair and what's the other one? We've got another bridge on the FVM as well. Sealer, they have issues with finality as well, because if you're trying to do a transaction from one blockchain to another, you've kind of got to wait for it to be final on one, because you could end up in an inconsistent state if something rolls back. So they have to make a risk judgment on how long they're going to wait for the finality. So if this helps with that, that'd be good as well. I can see a lot of people wanting to build as a result of that.
Okay, thank you.
Actually, one more comment. Like on token economics, also it's kind of important if we can, when we use IPC, we can like lock like a stake our token on L1 for the IPC. So like it's just for better token economics for our token. It's like creates more scarcity. Like we lock more tokens on the chain. It's sort of like also participates as a like this stake can be lost, so it's kind of participates in the IPC security, our IPC instance security, and also kind of takes token from the market, which is good for token.
Are you referring to creating POS subnet but having collateral in your own token?
yeah, sort of.
Okay.
Like, or maybe like fill and our token, or like
Okay.
just our token, something like that.
In this scenario, what would be used for gas in the subnet?
It depends. Like, could be even free transactions actually. Like, it depends on how you define it. Like, that actually could be also our token. Why not?
Yeah.
Right.
Are free transactions a concept right now? Like, is that?
We can subsidize it, right? You
Yeah,
can
no,
always-
no, no. But we've been having this, so I'm curious, like, what they're thinking about that. Like, I think we, like, for that tiling demo, we just embedded a wallet next to the actor that was just paying for everything so that it happened. But
Can you elaborate on like what's the use case for free transactions? Is it more along the lines how Internet Computer does like reverse gas model that developers pays for everything, or is it more that your business model is tied to some specific requests and everything else should go free?
Yeah, for us, it's about developer pays for everything. It's like, you in the cloud, developer pays for everything. In Web2 cloud, we want here same experience. We don't want users to pay.
yeah, they're just like adding flexibility on that halfway to that, like even being able to give like freemium sort of models, or like if you just because it's one that we did and we were playing with, if you look at that tiling demo that we created, and I said, okay, well, every transaction's happening there, so it's gonna be slow, so you'd have to slap a real CDN on it. Well, the solution that we're thinking of isn't for like millisecond transaction times anyway. So what could you do to make that better? Well, maybe you could put Saturn on top of it. But how is Saturn going to pay per transaction all the way back to our chain? Could there be some arrangement where Saturn actually is just getting free requests from something like that so that they can cache it and make it fast? I don't know.
Is it all going back to? Yeah, I'll transition to Alfonso in a second. But is it all going back to creating kind of general purpose web apps using decentralized technology? And in general purpose web apps, users don't pay for.
I think drilling into what he said, it's more like trying to create patterns that developers are familiar with.
Yeah.
Yeah.
Similar to like traditional centralized cloud. Yeah, cool. Alfonso?
And like so this is something that we are also considering. I mean, you should be able to deploy your subnet with no fees in transactions, especially for ephemeral, like Lilypad will need ephemeral execution subnets. Those may not need to pay for gas because you just agree. The only issue that I see there, like for the Lilypad case, it's clear, but for your case, for instance, how do we incentivize validators? Because like you're running a subnet for a SQL or like globally as the SQL orchestrator, and the issue that we're having with how to do free transactions is how to incentivize it. Like we would need some kind of off-band incentivization. So technically it's possible, but then who would be running the infrastructure then? That's our main issue with that feature.
Yeah.
If that makes sense.
Yeah. So this isn't so much a request from my part. It's more a question of how you're thinking about doing it, so we can figure out what designs are possible in that space. But actually, just leaning on his answer again, in that case, it's actually the developer pays. So there's still payment happening, but then the developer sets the rules for how that payment is getting allocated or used by people making requests, right? So, is there a design space to create something like that, or do we have to just take a step the other way?
Right, because here, let's say there would be a bunch of operations, like, I don't know, write operations, in your case, that would be paid, and then the read operations are the ones that you want to be free, for instance, right? Yes, that's the kind of like knobs that we want to play with in the gas model. So to be able to actually have this kind of complex incentive mechanics, but the issue is that there needs to be some kind of incentive. But it's really interesting, that one, because the flow of payments. So we've been discussing about a governance account, which is this account that you can have. So instead of like paying every transaction, there are certain transactions that are paid, and that goes to a governance account that is the one used to subsidize transactions from the other side. So that way, like, you balance the demand in some way. And that's kind of the thinking and the reasoning that we are having for this in order to support that. The problem is that fully free may not be easy because
But-
like then I mean maybe if you're subsidizing the validators or you're running the validators, that's fine. But if you're in a decentralized model, we need some kind of incentives in an open model.
And you can also print tokens, right? We can give Fluence tokens to those validators who run Fluence IPC subnet.
Oh
right?
yeah. You can yeah, sure. Like you can always subsidize as part of your subnet. That would work, yes.
You can also offer them chocolate, whatever you want.
For sure, yeah. But why not? This works as incentive. Why not?
Yeah, and actually more than that, like there's other models that we played with like a model. We were toying with different token models that might make that work, where you could actually have people staking to read, where maybe your token has an emission model, and the emissions from your stake go to the validators directly in order to get you read quotas against the database. Those sorts of setups that are more like nuanced than just like I'm going to pay for gas for every read. I don't know again if we're going to build that or anything like that, so I wouldn't design your roadmap around it. I'm just saying like.
kind of things that because even ephemeral subnets like
Yeah.
would give an additional value to running in subnets because I can tweak the gas model to whatever I need.
Yeah.
So it's definitely something.
I'm curious how you see the Lilypad ephemeral subnets working more easily with zero gas. Because I think that's what you said, and it's not immediately clear to me why that would be true. So I'm not challenging you, I'm just interested in understanding. Sorry.
Just use Andrews if you need.
Thanks. So I was thinking that so all of your interactions are in the parent, right? When you say I submit a job and I settle the job and so on, all are in the parent, and the only reason why you want the subnet is to run a actual consensus for you choose 3 service providers, you make them run it, and they need to agree on the result in order to commit it up. I want to commit it up. I mean, if you have this ephemeral subnet and you need to allocate some balance for the validators in order to agree and submit that result and pay for that gas, it may be messy. That's why I was thinking like transaction 0. You handle all of the money in the parent, and then this subnet is just running consensus on the service providers. I don't know if that makes sense.
Cool, that does make, I think that makes sense. I think my question then is, just to clarify, by the parent you mean like a middle subnet, not the mainnet?
Yeah, I mean,
Yeah.
you have the Lilypad subnet
Yeah.
that it runs all of the architecture that you mentioned, that orchestrates all of the job scheduling, all of the submit of the results and so on. And then what you're doing is, in order not to load that subnet, you spawn a new subnet for the job, but you need to submit the result to mainnet.
Okay, got it.
And you need to pay gas for that.
Yeah.
So we need to figure out ways in which we can afford these ephemeral subnets not to have to pay, or like to handle the payment already as part of the parent.
Okay, interesting. Yeah, my working assumption had been just that we would have a flat, like single IPC subnet to begin with. But then I guess your concern is that there would be too much load on that. Hence the desire
Maybe not.
for
This links with I think it was Kai, the one that mentioned the ephemeral subnets.
Oh, cool. Okay.
Yeah, it's more long term. I don't think this is going to be an issue.
Cool.
It's more an issue like for Tableland probably. And
Yeah.
Fluence.
We'll chat about it later. Sounds good.
But it's clearly interesting requirement to think about these models when developer wants to subsidize subnet and have more classic model. I think we need to double click on this in our future discussions. But there is a top question clearly in Menti, and it's how Fluence different from Lilypad. Do you guys think you have similar solutions that like in some friendly competition, or you think there is some critical differences between 2 products and approaches?
Well, I mean, obviously there is a difference from the architecture design, right? Like the solution design. And the way we kind of push and market Fluence right now, it's sort of like event-driven Lambda analogy. And I think like Lilypad has a little bit different positioning. So pretty much different, and a lot of difference. I know.
Yeah. So we've had some conversations, I think not with yourself, but with some of your colleagues. Yeah. And I can't remember exactly what the details were, but like what I do remember is the outcome of that conversation was I think we decided that there were like 2 different layers that we were tackling, and we could collaborate on like working with each other on the different layers. But I think there's a broader point here, which is that honestly, this space is so small right now, and we need to work together to solve these problems and to grow the whole pie. So like that's my kind of general business approach. And so yeah, happy to work with collaborators even if they're adjacent. Yeah.
Yeah, same. I think, I mean, like if it's the growing market, then like there's enough space for everyone. We're just experimenting with solutions. So who knows? We can steal ideas from each other.
Yeah, exactly.
Okay. Do we have any questions maybe in a live with a microphone? If not, I have enough questions here in Menti in my own list, but just in case. Okay, so I'll go to my next question is, what do you think is the biggest problem or missing feature with IPC?
I mean, moving ERC20 tokens around between subnets and parent, maybe, but we need to talk about that still.
Yeah.
Huh? No one wants that. Really? Oh, you're kidding. Okay. Yeah.
But we will want to know what is happening within the subnets from a high-level perspective, what is happening. So we will need the data of what they're doing, or we don't want to know this anymore. Like, how do we know how many subnets are being created? What are they doing? And how field is or tokens are being created? Yeah, what is
Observability.
Any other points? I would be interested to get answers from all of the panelists about like what do you think is the bottlenecks and missing features and gaps for IPCs that as you see it today. And the reason I ask you these questions, just like it will help us to kind of to prioritize our product roadmap and see what kind of the most important customers see as a constraint from IPC side.
Not as a technical thing from IPC itself, but kind of example documentation, starter kits, that kind of thing, and that's what I'd like to work on as well with the FVM and together with IPC is to try and get, okay, here's a simple thing, check out from GitHub, you can get it up, you can get it running, it's got your subnet. This is an example of how you move your ERC20 token from one to the other, whatever it might be, and how you can maybe observe it then once it goes through and all that lot.
Yeah, I agree. DX, we see from outside that DX is a clear kind of like a bottleneck for us, and we plan to invest in this space a lot, sometimes pulling forces with FVM team.
Besides what was discussed in previous question, the biggest bottleneck right now is IPC not yet ready.
Just build it. Come on.
Yeah,
come on.
that was just like basically the main solution. We delayed the using IPC. Like we looked at it, like okay, it's not audited yet. If we build on it now, we're gonna have like unknown risks, so which will delay our launch, and our launch is kind of public launch, so we have to delay because otherwise it's too risky. So that's the only thing.
Yeah, we hear you.
Thank you.
Us too. I think. Yeah, I was talking really fast, but so I'll just mention a couple that came up in that first test, which might just be a bad test for IPC anyway. So take it all with a grain of salt. But some of the things that we hit, and I've already heard some of them in the near-term solutions, but like we had to actually use a Fendermint fork, I think, to create our custom actor. It didn't have like full compatibility. Then actually calibration net didn't support us deploying custom actors at the time, so we had to just run our own network. We ran into this issue of the gas payments and like how you'd actually do like high throughput reads like to the subnet if they're on chain. That was a bottleneck. I think those were the. I'm sure there's others I'm missing, but we'll have the slides published so we can get some more notes there.
Can you tell me more about a problem of a lot of frequent reads?
The lot of frequent reads. Yeah, I think we just hit like the max throughput of the actor basically doing serial reads across the data. Like how quickly could you resolve those transactions?
As the reads were going through consensus?
Yeah.
Okay. Yeah. So there's measure.
Why do the reads need to go through consensus?
Yeah, like I was saying, it might not be the best use case for IPC. I was just explaining like things that we hit there that were bottlenecks.
Yeah, I remember my conversation with Sanders that they wanted kind of verified reads that they sure that information is completely non-modified.
Yeah, so the interesting use case we saw at that time that could be used there is that you could read straight from the database into other smart contracts in a verifiable way, those sorts of things. But
and there is a problem with this reads on UX level that you have to sign every transaction, so you need a special auto-signing wallets. That was the actually reason why we put auto-signing wallets in a roadmap.
So imagine like you have a smart contract on mainnet, and it could do a cross-chain message to the subnet to actually read a row of data. So.
Ali.
Wait.
Sorry, I'm not loud enough.
It's for the recording mostly.
Okay, so I'll just repeat myself. I just wanted to add on to Einhol's point about observability here. And I think one of the things that Web3 developers are really used to is having some sort of block explorer. And I don't think that exists on IPC. And I wonder how you are going to navigate that with multiple subnets doing different things as well. Or
I think it's a great question. So
Okay.
we're talking about this, that besides just having an explorer, you need to have some form of registry, like what subnets are out there, right? And you need to select it from the list or have some awesome like mind map type of like thing to navigate the hierarchy. Yeah, like when the subnet tree start growing, it will be a problem. We have it in mind, and we're thinking about it. But it's a great suggestion.
Yeah, and not just that, but we also need open source explorers because we need people, self-deployable explorers that can be deployed on your private subnet if you want. So.
We are building such an explorer. I wanted to ask, I'm a developer, and you were commenting fast and cheap. What are the advantages of me building using IPC compared to other layer 2s in other blockchains?
Sorry, I'm asking panelist or IPC team?
Well, panelist.
So the question is, you're a developer and you want to build something that could be an IPC subnet, or you want to?
Yeah, an IPC subnet. Yeah.
I think my other reasons for IPC would be good answers to that. Like, if it has good interoperability with storage, for example, that you can't get on other chains. So that was a biggie.
Yeah, and another one is EVM and WASM together. This was actually the reason why we were, like one of the biggest reasons besides getting close to data why we were started building on Filecoin. Because like it allows EVM and WASM on chain, and you can run some stuff in WASM faster, more efficient, or like you can reuse existing code and run it on chain. So like ideally in IPC you also have EVM and WASM together, so you can have smart contract that does calls to WASM actors and get responses back. And this is kind of sort of unique feature. Like there is Aurora in Near besides it with this implementation. There is a Cosmos, some chain on Cosmos.
Arbitrum's just recently come out with one.
Also with WASM? Oh, nice. Okay, yeah. So, but like this is good differentiating feature to look at IPC.
Yeah, I was just going to say, we get a lot of people at hackathons come up to the booth and say, why should I deploy on Filecoin and not on whatever Polygon? And we get a lot of people that deploy to Filecoin in hackathons, purely to get the bounty, right? Being honest there. Really, it's about storage, and we know that story is not really very good at the moment still. So, but hopefully, there's a number of things going on that will improve on that, ability to interact with storage from there. But yeah, I mean that's the killer feature of Filecoin, right? That's the main USP. If that doesn't appeal to you, then really, then maybe there isn't. We shouldn't be forcing people, or not forcing people, necessarily. Saying that it's the right solution for them. There might be other general purpose blockchains that might fit their needs better for that. But I mean, I hadn't even thought about that, about the WASM and Solidity, side by side. I think that is an interesting one. And like I said, we were just at a conference, and right next to us was Arbitrum, and they were one of the big features they had was a new service they have, which is exactly that. So it's it seems to be something that is worthy of pushing. So yeah.
Actually, can you do your own Arbitrum chains, or like you build on their other two?
I don't know.
Because in this case, actually, IPC is the only solution that allow you to have your own
subnet,
own subnet, which would have EVM and WASM. Like all others, they provide EVM and WASM on public chain, and building on public chain is like not great for application if you wanna if you don't need too much interoperability with others, and if you predict like a big scale, that building on public chain is not option.
Yeah, and if you take that a step further with the idea of if you've seen Rahul Kripalani's talk on the yellow runtime he's working on, the idea from that, from what I understand, is it allows you to basically define what your blockchain is going to be in a simple way, using a configuration file. You can say, okay, I want this subnet, and I want this runtime, and I want this block time, and I want this and configure it and spin it up. And like you said, that would be the only blockchain that allows that at that level. So that'd be really interesting. Yeah.
You reminded me of another question / bottleneck that came up back then, which maybe you know the answer to already, which is we hit that issue where when you write WASM applications, you have to decide what environment they're going to run in so that you can have randomness or not. Will you have randomness in your environment? Like, can you use random in your WASM?
Question for Alfonso, I think.
I mean, we don't have WASM right now, but I'll hand this to Alfonso. But yes, so Arbitrum with Orbit, I think they're also planning to have customizable subnets, but I don't know how far they are in that roadmap.
How often do you need randomness? Because we have the syscall from the FVM, from DRAND.
Yeah.
And so that's the only randomness we currently support.
Yeah, I forget why we were using it in that first example, but yeah, it was one of the cases we hit where we had to just use the environment that could access Unix randomness, I guess.
Yeah. No one has used randomness so far. Like, they use the syscall from.
How are you just using DRAND randomness when you were talking?
For the smart contract, they don't need that, right?
I think, Kai, yeah.
To be honest, it's almost just like, it's pseudo randomness we're using. We don't actually need true randomness, and the design of the system doesn't really care which one is picked. It's just pick one without any kind of like, hey, I can game it by appearing first in the list, but it's not that important which one gets picked. So it's like shrug random.
Yeah, actually, I just remembered why we did it, and it probably isn't a good use case. But to get SQLite, even to compile to WASM, you have to have it, and so it's a shortcut. Like, we could rewrite SQLite without it, but.
And they're not using them still.
George, how are we on time?
We're 5 minutes over. We started over as well. But, FYI, the break is being served downstairs, but we can keep going for a few more minutes if people are.
I think I will ask last question, which is for Matt, actually. And I see there is a long list of questions for Fluence, and I wonder if we can squeeze in somehow some form of Fluence Q&A session, because they're not applicable to the rest of the panelists. I'll chat with George after this. Matt, there's a question specifically for you. What use cases you see are really good fit for IPC?
Good question.
Sorry for putting you on the spot.
Yeah. So one of them is to do with, like I mentioned, is actually to do with the finality side of things, right? So if you're trying to run something like a bridge, somebody's trying to move a token from one blockchain to another, and then the transaction kind of goes through and it goes, okay, this side's done. Now the other side, you've got to wait 7.5 hours, right? Or an hour or 2 hours or whatever they're going to pick as their their sort of finality, sort of happiness with how final the transaction is. That slows everything right down and hurts the user experience a lot. So if there's, that would be a very good use case for when people are sort of moving tokens on and off. But we see a lot of builders, again, especially within hackathons, often they're using, especially something like Polygon, they almost just use it a bit like a database in some ways, about storing state or storing some sort of information, getting it back in, wanting to do it fairly rapidly. Probably be a very, very good case for them to be using Tableland in that case, and then Tableland on IPC would then make that a lot cheaper for them to do that. So yeah, I think that's the one where they're updating something fairly regularly. We're seeing people starting to do stuff with like gaming. So, gaming, and they've got some storage. So they're storing some game assets or something like that, some whatever it might be they want to store that on Filecoin or an IPFS. And then they have a smart contract. And as within the gameplay, it's being updated fairly regularly. They need something to be fairly cheap in order to do that and fast in order to do that. So I think that's where it is. If you're storing a petabyte of data, on Filecoin and need to, post something back to verify that it's done, then it's, you're not going to be worried too much because the actual process of the storage deal is going to be taking hours anyway. So you're not going to be too worried about that. But it's probably more the cases that don't, not talking about sort of large or long-term storage of data, but, more sort of immediate use cases.
Cool. Okay, I think we should wrap up. And thank you very much for participating. And if there are additional questions, you can find the panelists in the room. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.